We introduce an interactive 3D editing method via text prompts. Here's an example. Our method is centered around a large language model that allows for arbitrary textual input from users and interprets their intentions, subsequently facilitating the autonomous invocation of the corresponding visual experts to achieve the editing of the scene. The emergence of LLMs, such as ChatGPT, signifies a new stage in human-computer interaction. However, the existing 3D scene editing methods constrain the deployment of LLMs in 3D scene editing tasks. We summarize these typical frameworks in this figure. The iterative methods require iteratively embedding of information from 2D visual models into 3D scenes. Supervised approaches rely on 2D models to supervise the reconstruction process. Denoised methods necessitate the prior modeling of inconsistency in the 2D editing model. These coupled designs are often intricate, making it difficult to flexibly integrate diverse visual models and thus hindering the deployment of LLMs to respond to diverse user queries and demands. Therefore, we develop a mapping network called HashAtlas. Given the views of a 3D scene, FM first maps each pixel coordinate from the views to two UV spaces and predicts the transparency of the foreground atlas. Subsequently, FH predicts the RGB values at each coordinate in the UV space, thereby obtaining the foreground and background atlases. This innovative design translates the editing of 3D scenes into the manipulation of 2D atlases. When the atlases are edited, they can be mapped back to the original scene views, thus decoupling the editing and reconstruction processes to avoid the intricacies of conventional pipeline architectures. By employing the LLMs, we propose a dialogue framework for editing 3D scenes, termed CE3D. Given the user's text query, ChatGPT interprets the text and determines whether visual tools are required for this dialogue. When visual tools are needed, it will call the desired tools from the model zoo. The backend further queries the atlases and other files to be invoked. In addition, if the atlases do not exist, the backend first acquires them using the HashAtlas network. The executor executes visual tools to edit the atlases and feeds back new status to ChatGPT for subsequent actions. The edited atlases are then mapped back to the 3D scene views through the HashAtlas network for later scene reconstruction. Then the front end responds to the user with the editing results and ChatGPT's outputs. Here, we show the multi-round dialogue editing results of our method. For various editing abilities, state-of-the-art methods show limited editing performance. In contrast, the proposed CE3D offers facile compatibility with various 2D visual models, thereby enabling diverse editing functionalities. For different text queries, IN2N produces notably varied results when the accompanying text varies, while CE3D possesses stability in the editing outcomes. Here we show comparisons with IN2N for multi-round dialogue. The IN2N method lacks sufficient editing capabilities and falls short in text parsing, making it challenging to handle complex multi-round dialogue tasks. By introducing a decoupled novel editing framework, our method effectively addresses these challenges and outperforms IN2N significantly. In summary, in this work, we identify the challenges in deploying LLMs within 3D editing tasks, including convoluted design and poor scalability in current approaches. We introduced the Hash Atlas network, which maps 3D scene editing operations onto executions within the 2D atlases, thus achieving decoupling between 2D editing and 3D reconstruction processes. We propose CE3D, which integrates LLMs to manage multiple visual models, realizing an interactive scene editing system with enhanced editing capabilities and accurate text recognition. Compared to previous methods, CE3D possesses more robust text parsing capabilities, richer editing capabilities, and more natural interaction.